M4 rocket का
Underneath the quiet exterior of the moon, important findings have come to light that worries respected physicist Michio Kaku. The spacecraft Chandrayaan-3, exploring the lunar surface, has revealed surprising information hinting at a puzzling and possibly worrying truth. As word of these unexpected discoveries spreads fast, global tension rises, leading to heated debates. What is it that has left Michio Kaku panicking over the shocking things Chandrayaan-3 saw on the moon? Could it be an extraterrestrial mystery etched in the lunar landscape, testing the core of our understanding of the cosmos? Join us as we explore Michio Kaku's concern over the surprising discoveries made by Chandrayaan-3 on the moon. Witnessing Pragyan rover's moon arrival through Vikram's eyes. The remarkable journey of the Vikram lander and the Pragyan rover on the moon's surface is beautifully captured in a breathtaking video. This footage offers a glimpse into the meticulous process as the Pragyan rover descends gracefully onto the lunar landscape, with Vikram's specialized camera positioned to document this historic moment. As the video unfolds, the Pragyan rover navigates its way down a ramp extended from Vikram's underside. The descent is deliberately slow and cautious, allowing the rover to approach the moon's surface with precision. In the background, Vikram lander maintains a vigilant stance, overseeing the rover's progress. Amidst this stunning visual, the audio from the Mission Control Center punctuates the silence, providing crucial updates on the status of the descent. It's crucial to grasp that while the team on Earth is in charge of the mission, the vast distance between our planet and the moon causes a delay in communication. A command takes approximately 1.3 seconds to reach the moon, with an equal delay for a response to return to Earth. This communication lag necessitates that the lander and rover operate autonomously, relying on their internal systems. These machines are equipped with sophisticated computers and sensors, pre-programmed to execute this intricate operation independently. Their success hinges on their intelligence and capabilities to navigate and land safely on the lunar surface. This video is evidence of the seamless collaboration between Vikram lander and Pragyan rover, highlighting their synchronized efforts in achieving this monumental feat. This collaborative effort marks a historic milestone in space exploration, showcasing the incredible technological advancements and the remarkable teamwork between these two entities. The significance of this achievement lies not only in the successful landing, but also in the demonstration of the effectiveness of autonomous systems operating in a challenging environment such as the moon. However, the plot thickens at this juncture, adding a layer of intrigue. From Luna 9 to Vikram lander. After the successful lunar landing, the Pragyan rover captured a remarkable image of the Vikram lander standing tall on the moon's surface. This photo was taken using the Pragyan navigation camera located on its front side. Additionally, there's another footage demonstrating the Pragyan rover's adept navigation across the lunar terrain, skillfully avoiding potential hazards. In the image, the Vikram lander stands upright, supported by its four legs, positioned on a flat area near a small crater. The main engine at the bottom played a crucial role in decelerating the descent and ensuring a gentle landing on the moon. This image provides clear proof of India's successful moon landing, an accomplishment not easily achieved. Only Russia, the USA, and China have previously achieved this remarkable feat. You see, in the year 1966, space exploration took an incredible turn with Luna 9, a mission launched by the Soviet Union. This mission holds a special place in space history for achieving the very first gentle landing on the moon. Luna 9 didn't just touch down successfully. It also gifted humanity breathtaking, wide-ranging views of our closest cosmic neighbor, the moon. This spacecraft wasn't your typical creation. It looked like a round capsule, a groundbreaking and carefully planned design. Weighing only 199 kilograms and measuring just 58 centimeters in diameter, Luna 9 came equipped with groundbreaking features. What made it stand out were four pedals that served a dual purpose. When it landed, these pedals played a crucial role in steadying the craft while revealing its essential tools. Among its cargo were cutting-edge components, a radio system for communication, top-notch radiation detectors, and a vital system to control temperature. This temperature control system was vital in handling changes in heat, ensuring the mission's equipment worked properly and lasted long. Luna 9 was special for its TV camera on a spinning base, taking amazing pictures of the moon. These images showed the moon's rough landscape, full of craters and hills that hadn't been seen before. They were so captivating that they made headlines worldwide, even in big newspapers like the Daily Express. People at England's Jodrell Bank Observatory got these images and got super curious about space beyond Earth. But Luna 9 did more than take pictures. It checked the moon's temperature from super cold at minus 153 degrees Celsius at night to scorching hot at 123 degrees Celsius in the day, showing how different the moon's atmosphere is. It also measured pressure and radiation levels, giving us important info about the moon's environment for future explorations and maybe even living there. The spacecraft even experimented by pushing a rod into the moon's soil and found it was pretty strong, suggesting it could support future missions. This crucial finding hinted at the strength of the lunar surface, suggesting it could support future landers and rovers, marking a pivotal milestone for upcoming missions. However, as is often the case with such missions, Luna 9's adventure had a limited duration. Its mission came to an end when its batteries drained after approximately 3 days on the moon's surface. Nevertheless, within this brief period, the spacecraft transmitted a total of 8 captivating images, along with invaluable scientific data that will continue to shape our understanding of the lunar landscape and aid in planning future missions. Chronicles of Lunar Exploration. Luna 9's mission in 1966 was a turning point in lunar exploration, setting the stage for further ventures. Following its path, Luna 13 set off on its lunar journey on December 24 of the same year, significantly contributing to our understanding of the moon. This subsequent mission echoed Luna 9's goals, diving deeper into lunar exploration and enhancing our knowledge of the moon's nature and features. Luna 13's efforts in 1966 solidified our foundation for future lunar expeditions. But the pinnacle of human space exploration arrived with the monumental Apollo 11 mission in 1969, reshaping our cosmic understanding forever. Beginning on July 16 from Florida's Kennedy Space Center, this mission represented the climax of the ambitious Apollo program. Its primary objective was to safely transport humans to the moon's surface and ensure their return to Earth, a task taken on by 3 extraordinary astronauts. Neil Armstrong, the mission's commander, etched his name in history by becoming the first human to step foot on the moon. His iconic steps were followed by Edwin "Buzz" Aldrin, the lunar module pilot, while Michael Collins orbited the moon in the command module. Apollo 11 epitomized a feat of engineering and innovation, comprising 3 fundamental components: the command module Columbia, the service module providing life-sustaining resources, and the heart of the mission, the lunar module Eagle. The Apollo 11 mission lasted approximately 8 days, filled with excitement, wonder, and historic breakthroughs. Departing from Earth, the spacecraft maneuvered towards the moon's orbit, a pivotal achievement, by July 19. On July 20, Armstrong and Aldrin descended aboard the lunar module, landing gently on the tranquil plains of Mare Tranquillitatis, the Sea of Tranquility. Armstrong's famous words echoed globally as he took humanity's first steps on the lunar surface. For about 2 hours, the duo conducted scientific experiments, collected valuable samples, planted the American flag, and set up crucial instruments. Meanwhile, Collins captured photographic evidence of the lunar terrain from the command module. Upon completing their tasks, Armstrong and Aldrin rejoined Collins on July 21, bidding farewell to the lunar module and initiating their return journey to Earth. Their successful re-entry culminated in a splashdown in the Pacific Ocean on July 24. This historic mission was packed with scientific endeavors and meticulous planning. Experiments on the lunar surface aimed to unravel mysteries and gather crucial data. Scientific instruments deployed included seismic instruments to measure moonquakes, solar wind measurement devices, and a laser reflector for precise Earth-Moon distance measurements. These experiments advanced our understanding of lunar geology, the moon's composition, and even Earth's place in the cosmos. The collection of lunar samples wasn't merely souvenir gathering. Scientists extensively studied them to learn about the moon's formation and evolution, shedding light on Earth's history. The return journey was meticulously planned, considering the complexities of space travel. Re-entry into Earth's atmosphere subjected the spacecraft to intense heat, but it was designed to endure this fiery ordeal, ensuring the astronauts' safe return. Vikram's legacy. In 2023, the world of space exploration witnessed an awe-inspiring achievement through India's Chandrayaan-3 mission. This mission wasn't just significant for India, but captivated the global space community by aiming for a controlled touchdown near the mysterious south pole of the moon. This lunar area, famed for its scientific intrigue and complexities, held the promise of unveiling new lunar secrets. Chandrayaan-3 was a mission marked by its intricate planning and diverse goals, featuring 3 key parts, each assigned specific roles. The orbiter, like a vigilant guardian in the sky, carried 8 cutting-edge scientific tools. Positioned in a circular orbit about 100 kilometers above the moon's surface, its primary task was to meticulously examine the moon's landscape and atmosphere, collecting a wealth of detailed information. Accompanying the orbiter was the lander, named Vikram in honor of Dr. Vikram Sarabhai, the visionary behind India's space agency. More than a mere tribute, Vikram was a robust machine armed with 4 specialized instruments. Its mission? To gather crucial data on various aspects like temperature fluctuations, seismic movements, plasma density, and surface composition, all specifically tailored to its designated landing spot. The meticulous planning and sophisticated equipment of Chandrayaan-3 showcased India's growing expertise in space technology and exploration. By focusing on the moon's south pole, the mission strategically aimed to explore uncharted territories, unlock lunar mysteries, and deepen our understanding of this less explored lunar region. The selection of scientific tools on both the orbiter and lander highlighted the mission's thorough approach to studying the moon's surface, atmosphere, and geology. These instruments were carefully designed to gather a wide range of data, paving the way for significant progress in lunar research. Pragyan, true to its Sanskrit name meaning wisdom, embarked on a journey that meticulously revealed the lunar landscape. With 2 advanced instruments, Pragyan diligently uncovered intricate details about the moon's minerals and the composition of its soil, delving deep into lunar mysteries. The expedition began on July 14, 2023, as the Polar Satellite Launch Vehicle rocket carried Chandrayaan-3 from the Satish Dhawan Space Center in Sriharikota, India. However, this mission didn't take a direct path to the moon. Instead, it engaged in a strategic orbital maneuver around Earth for over a week, gradually building up the necessary momentum. On July 21, 2023, Chandrayaan-3 moved into the next phase of its mission through a precisely executed trans-lunar injection maneuver. This precise maneuver positioned the spacecraft to be captured by the moon's gravitational pull, setting it on an elliptical orbit around the lunar body. The ISRO team showcased their exceptional precision engineering skills by meticulously fine-tuning the spacecraft's path through a series of carefully coordinated maneuvers over the following weeks. They aimed to precisely position Chandrayaan-3 in an ideal circular orbit, maintaining an altitude of around 100 kilometers from the moon's surface. By August 19, 2023, this intricate objective had been flawlessly accomplished. Chandrayaan-3 gracefully orbited the moon at the desired altitude, marking a significant milestone for the ISRO team. This achievement not only highlighted India's technological strength in space exploration, but also demonstrated the team's expertise in orchestrating intricate maneuvers across vast cosmic distances. Vikram's high-stakes touchdown. On August 23, 2023, following a series of intricate orbital maneuvers performed by Chandrayaan-3's orbiter around the moon, the crucial moment arrived for the lander Vikram to undertake its daring descent towards the lunar south pole. Parting ways from its parent orbiter, Vikram faced the daunting challenge of executing a controlled landing on the lunar surface, a task resembling a high-stakes tightrope walk from space to a celestial body. Descending from space towards the moon posed a monumental challenge for Vikram. Initially hurtling at a swift speed of 1.68 kilometers per second, the lander carefully utilized its onboard thrusters to gradually slow down, meticulously reducing its speed to nearly a complete halt. Yet, managing speed wasn't the only challenge. As Vikram approached the moon, it had to make precise adjustments to its path and orientation, akin to a pilot making final corrections during a landing to ensure a safe touchdown for all on board. Vikram exhibited remarkable precision during this critical phase, executing calculated maneuvers to position itself amidst two lunar craters, Simpelius N and Manzinus C. This specific area was renowned for its harsh environmental conditions, with temperatures dropping to an icy -240 degrees Celsius. Furthermore, sunlight was a rare occurrence in this zone, sporadically reaching the lunar surface due to the region's unique terrain and alignment with the sun. Despite these complexities and challenges, Vikram adeptly settled itself in this demanding terrain, laying the groundwork for the following stages of its mission. The flawless execution of this descent highlighted the expertise and detailed planning of the mission team, showcasing India's ability to conduct sophisticated lunar operations, even in the most unforgiving lunar landscapes. The spot where the spacecraft landed was picked carefully because it was a smart choice. They wanted to explore an area on the moon that had special qualities. They hoped to learn a lot about what the moon is made of, what its rocks and land look like, and what the environment there is like. After it landed successfully, Vikram got right to work. The part of the spacecraft that touches the ground unfolded its solar panels smoothly. It looked a bit like wings spreading out after a long trip. But these panels weren't just there to look cool. They were super important. They needed them to power up all the cool tools and gadgets the mission brought along and to make sure the spacecraft worked well. As the panels opened up, Vikram also stretched out its antennas. These antennas were crucial because they made a connection with the orbiter flying above. That connection was important because it was like a phone line between the moon mission and the scientists back on Earth. It let them talk in real time, which was super helpful. That way they could send all the information they were collecting, and scientists could watch and study what was happening on the moon as it was happening. After the initial steps, the mission on the moon was just getting started. Picture waiting for all the dust to settle after a strong wind on Earth. That's what needed to happen on the lunar surface. There was a short time for all the moon dust to clear out. Meanwhile, the lunar rover, Pragyan, patiently waited for its chance to spring into action. Finally, when the signal was given, Pragyan rolled down Vikram's ramp, filled with both curiosity and a clear mission. Think of the rover as an adventurer stepping foot on a completely untouched island, eager to explore. Pragyan had roughly the length of a single lunar day, like a fortnight game round, to get its job done. It had a specific distance it could travel, about half a kilometer away from its main base, Vikram. Pragyan was built to be independent, like it had a mind of its own. It had its own set of cameras and sensors, just like the eyes and instincts of a rover. These tools were super important for Pragyan to move around the bumpy and unpredictable moon's surface. They made sure Pragyan didn't trip over rocks or get stuck in tricky spots. The art of frugal space exploration. India's Chandrayaan-3 took a bold step into unexplored lunar landscapes down at the moon's south pole, not only marking historic achievements, but stunning many with its exceptional financial efficiency. This mission showcased India's knack for merging cost-effectiveness with cutting-edge space innovation, all within a tight budget of a mere $74 million. K. Sivan, the former chairman of ISRO, revealed that the entire mission's spending stood at around 615 crore rupees, roughly equivalent to $74 million. Within this budget, the expenses broke down. Approximately 215 crore rupees went into the lander, rover, and propulsion module, while the launch services amounted to about 365 crore rupees. This meticulous budgeting shone brightly when compared to Chandrayaan-2, its predecessor. which had a significantly larger budget of 978 crore rupees, or $96.5 million, despite facing an unsuccessful landing in 2019. Contrasting Chandrayaan-3's financial plan with other global lunar missions starkly highlighted its cost-effectiveness. For example, Russia's Luna 25 mission, aiming for the same lunar South Pole but ending in a crash, operated on a budget nearing $2 million. NASA's ambitious Viper rover project, set for 2024, was expected to cost a hefty $433 million. China's Chang'e 4, successfully landing on the moon's far side in 2019, had a price tag of around $180 million. Chandrayaan-3's success in cost-effectiveness owed much to its smart design. The combined weight of its lander and rover was merely 1.4 tons, significantly lighter than many international counterparts. For example, NASA's Viper rover alone weighed about 1 ton. This strategic lightweight approach slashed various costs, especially those linked to launch and fuel. But it wasn't just about weight. Chandrayaan-3's financial efficiency also stemmed from its clever use of existing technology. India made use of its GSLV Mk3, a robust rocket with a proven track record from prior successful missions. Moreover, instead of starting from scratch, the lander and rover for Chandrayaan-3 were adaptations and enhancements from Chandrayaan-2's designs. Despite financial challenges, Chandrayaan-3's mission faced and overcame various hurdles. Its cost-effective strategy, innovative design, and shrewd use of technology paved the way for significant accomplishments within a limited budget, setting a remarkable example for efficient space exploration. Chandrayaan-3's 17 minutes of triumph and tension. India's third lunar mission, Chandrayaan-3, embarked on a challenging voyage filled with obstacles, from its takeoff to its final touchdown. This grand venture began with the daunting task of achieving the precise lunar orbit, initiated by the powerful GSLV Mk3 rocket lifting off from the Satish Dhawan Space Center in Sriharikota on August 15, 2023. However, reaching the moon was no straightforward journey. It demanded intricate precision. The spacecraft navigated through intricate maneuvers utilizing its engines and gravitational forces from both Earth and the moon. Positioning it precisely around the moon was crucial as it determined the course for landing. Their goal wasn't just to circle the moon, they aimed for the untrodden South Pole, anticipating discoveries like ice and other valuable resources. Yet, this chosen location posed significant challenges: rugged terrain, extreme temperatures, and potential communication issues for the Chandrayaan-3 team. Selecting the landing site was a monumental decision, requiring a delicate balance between factors like sunlight exposure, a safe landing spot, and communication with Earth. This decision held immense weight as it directly impacted the mission's success and the rover's ability to explore the lunar surface effectively. Then came August 23, 2023, a tense 17 minutes known as the 17 Minutes of Terror. This critical phase was when the lander, Vikram, had to rapidly decelerate from incredible speeds to execute a safe lunar landing. What heightened the tension was Vikram's solo performance. It had to autonomously make split-second decisions on maneuvering and precisely determining its landing spot without real-time assistance. Miraculously, Vikram succeeded, granting the rover, Pragyan, the green light to commence its exploration on the lunar surface. Pragyan, the rover, had its share of tough moments. Moving across the moon's dusty and rough surface needed careful navigation to dodge obstacles and keep talking without any interruptions. But even after the successful landing, the challenges didn't stop there. The lander and rover had a super tight schedule, just 14 Earth days, which is like 1 day on the moon, to get all their work done. They rushed to do experiments, study the moon's soil, check temperatures, and gather crucial info to send back to Earth. The problems they dealt with were pretty complicated. The moon's temperatures were extreme, going from a freezing minus 180 degrees Celsius to a scorching 100 degrees Celsius. That made everything hard. Sometimes they couldn't talk to each other because the communication would suddenly stop, and dealing with all the space radiation was tough too. Figuring out how to use power in this harsh place was another big challenge. But even with all these problems, the Chandrayaan-3 mission kept going, pushing the limits of what we know about the moon and helping us understand its mysteries better. Now it's time for today's subscriber pick. In the field of space exploration, a recent discovery has sent renowned physicist Michio Kaku panicking over the shocking things Chandrayaan-3 saw on the moon. You see, the Pragyan rover, designed for lunar exploration, combines intelligence and durability to navigate the moon's challenging terrain. Beyond its robotic nature, the rover exhibits curiosity, constantly seeking uncharted lunar territories. Utilizing laser-induced breakdown spectroscopy, LIBS, it analyzes lunar soil, unveiling crucial chemical compositions. The rover's focus on the South Pole region, emphasized by Michio Kaku, holds significance for its unique characteristics and potential as a base for future missions. The discovery of water in this area adds strategic value, potentially fueling rockets for space exploration. LIBS reveals a surprising abundance of sulfur in the lunar soil, a pivotal element in life and volcanic processes, suggesting meteorite impacts. This discovery reshapes lunar understanding, offering prospects for exploration and colonization. The rover also identifies various elements, including magnesium, aluminium, silicon, calcium, titanium, iron, and sodium, unlocking keys to the moon's geological evolution. Michio Kaku underscores the importance of these findings for comprehending lunar history and advancing future lunar endeavors. Let us know what you think about this in the comments below. Chandrayaan-3's revelations at the South Pole. The Chandrayaan-3 mission marked a crucial milestone by touching down on the moon's near side, specifically landing at the Shiv Shakti point, roughly 600 kilometers away from the South Pole. Unlike China's Chang'e-4 mission, which successfully landed on the moon's far side, Chandrayaan-3 confronted unique hurdles due to the rugged landscape, never-ending darkness, and extreme temperatures of the South Pole. The moon has two distinct sides: the near side, visible from Earth, and the far side, perpetually hidden from us due to how it orbits. Chandrayaan-3 chose the near side, dealing with the challenges posed by the rough mountainous terrain of the South Pole, filled with vast craters, deep trenches, and steep slopes. Selecting a safe spot to land became a major challenge in itself. Moreover, the perpetual darkness near the South Pole, caused by how the moon tilts on its axis, and the presence of deep craters, brought about issues for missions relying on solar power. Certain areas near the South Pole hadn't seen sunlight for over 1 billion years, making it incredibly difficult to generate energy for the spacecraft's operations. On top of that, temperatures in this region could plummet to as low as -230 degrees Celsius during the lunar night, potentially harming electronic parts and making it hard to keep the spacecraft warm. Despite these enormous challenges, Chandrayaan-3 was engineered to survive for only 14 Earth days, or one period of lunar daylight. In that short span, the mission managed to make several significant discoveries despite the harsh conditions. The Vikram lander went on a mission to explore two important parts of the moon, the exosphere and the ionosphere. The exosphere, which is almost like a space, has a tiny pressure, about 0.3 nanopascals. Then there's the ionosphere, which gets all charged up by sunlight, making a thin layer of plasma around the lunar surface near the South Pole. This plasma stuff is crucial for radio signals to travel, and they found out it changes as the lunar day goes on. The thin plasma layer suggested that there wouldn't be much delay for sending signals or navigating, which is super important for future people living on the moon. The team also found out some interesting things about temperatures just below the lunar surface. It gets really hot during the day, about 60 degrees Celsius, but just a bit under the surface, like 8 centimeters down, it gets super cold, around -10 degrees Celsius. This change in temperature shows that the top layer of the moon works like a really good insulator. That's great news because it might help in building safe places for astronauts to live, shielding them from the moon's extreme weather. They made a big discovery with a tool that listens for movements on the moon's surface. They found something that seemed like a moonquake. These quakes can last for a short time, from a few seconds to an hour. They happen because of things like big impacts, the pull from Earth and the Sun, or temperature changes. Finding this quake was a first, and it made scientists think there might be things happening deep inside the moon. They've got some ideas like the moon might be getting smaller or heating up inside, making pockets of hot stuff. The rover they sent, called Pragyan, used a special tool to find out what elements were there. They found a bunch of different elements like aluminium, calcium, chromium, iron, manganese, oxygen, titanium, and silicon. But one thing that got attention was sulfur. They hadn't seen much of that in the moon's south pole before. Finding sulfur is a big deal because it helps us understand how the moon is made and what its history might be like. And knowing it's hanging out near water ice spots on the moon adds more to the whole exploration of water up there. Renewed hopes in the quest for lunar water ice. Despite the amazing discoveries made by the Vikram lander and the Pragyan rover while exploring the moon, they couldn't find something really important: water ice. Back in 2008, India's Chandrayaan-1 mission spotted signs of water molecules in the moon's polar areas using a cool instrument called the Moon Mineralogy Mapper. They spent over 10 years looking at all the data from that mission, and in 2018 they used it to confirm that there's water ice on the lunar surface. But here's the twist. The Pragyan rover, just like the missions before it, couldn't directly find this water ice. Instead, it found sulfur, which could mean something else entirely. So, where's the water ice that Chandrayaan-1 saw in 2008? There are a couple of ideas. First, maybe the Pragyan rover landed in a spot where there's no water ice at all. That 2008 study said that ice isn't spread out evenly on the moon. It's bunched up more in some craters near the southern pole and not as much in the areas near the northern pole. Second, there's another discovery from Chandrayaan-3 that might help explain this. They noticed that the ground just below the lunar surface gets cold. This makes scientists think that instead of being right on the surface, the water ice might be hiding deeper down inside the moon. Chandrayaan-3 tried to make contact after the moon's night, but sadly they didn't get any response. Even though they couldn't do that, the mission was a hit. They managed to land the spacecraft softly on the moon and gather loads of useful data while it was coming down. People know that the south pole of the moon is a treasure trove of resources, and India's Chandrayaan-3 played a big role in helping us understand more about it. Now, India and Japan are teaming up for Chandrayaan-4. They plan to use a lander and a rover to directly hunt for that tricky water ice in the southern pole region of the moon. Thanks for watching, and we'll see you in the next one.